When we think of hydropower, the image that usually comes to mind is huge dams like the Hoover Dam, massive structures holding back rivers to generate electricity. And while those are important, they only tell part of the story that hydro has to offer. There's an entire world of hydropower that doesn't rely on dams at all. Oceans, rivers, and tides offer enormous energy potential, and we can harness that power without altering the landscapes or ecosystems as drastically. So, what is it? Where does it come from? How is it used today? And how could it shape our future? Humans have been using the motion of water for power for centuries, long before electricity even was discovered. In the Middle Ages, tidal mills were used to grind grain. These early systems used rising tides to fill a pond, then release the water through a wheel as the tide went out. Fast forward to 1966 in France, the La Rance tidal power station was completed and became the first large-scale tidal power plant in the world. It's still running today and produces about 240 megawatts of electricity. Around the 1970s and 80s, scientists and engineers started thinking beyond rivers and dams. These ideas led to early prototypes of wave energy converters and marine turbines, technology that didn't get much attention at the time, but has recently come back into focus thanks to climate change and the global push for cleaner energy. Now, there are four main types of non-dam hydropowers that we should look at. There's tidal power. Tidal power harnesses the natural rise and fall of the oceans. It can be done in a few ways, such as tidal barges, which are kind of low-like dam that let water in and out through the turbines. Tidal lagoons, which trap tidal water and release it to spin turbines, or underwater tidal turbines that spin as water flows through them, like wind turbines just on the ocean floor. One major advantage is that tides are predictable, so you can always count on when the energy will be produced. There's also wave energy. Unlike tidal energy, wave energy comes from the wind blowing over the ocean's surface. Special devices capture the up and down motion of the waves. Some float and move with the waves, turning that motion into energy, while others sit under the water and capture pressure changes. Some use chambers that trap air and water movement to spin turbines. Water energy has huge potential. According to the U.S. Department of Energy, the power from waves hitting the U.S. coastlines could help produce up to 2.64 trillion kilowatt hours per year. That is enough to power over 200 million homes. There are also run-of-the-river systems. These systems generate electricity from naturally flowing rivers. No big reservoirs are needed. Water is diverted through a small turbine and then flows right back into the river. These systems are especially useful in remote areas because they can provide power without major infrastructure or environmental disruption. There are also underwater turbines and marine current turbines. Essentially, imagine placing wind turbines underwater, where strong ocean currents or tidal flows pass through. Water is about 800 times more dense than air, so even slow currents can generate a lot of force. These turbines are still being tested around the world, and in places like the Big Bay of Fundy in Nova Scotia and near the coast of Scotland are where they are being tested. They are also low profile, operate silently, and have a minimal footprint, making them ideal for places where protecting ecosystems matters. Now, currently, non-dam hydropower makes up a small part of global energy, less than 1%. But that's not because it doesn't work. It's because the technology is still new and expensive to scale. Some standout examples include the Shiwa Lake Tidal Power Plant in South Korea, which powers over 100,000 homes. The Meigin project in Scotland is the world's largest tidal stream array, and the Annapolis Royal Generating Station in Nova Scotia, which was recently shut down, but helped pave the way for future marine energy projects. These power sources are gaining specific interests for uses like isolated coastal towns that are connected to power grids, aquaculture farms that need reliable off-grid energy, and desalination plants to convert seawater to drinking water. Even data centers, which require constant power and cooling, could be built next to a tidal or wave energy farm. Governments and private companies are investing more than ever. For example, the U.S. Department of Energy has funded multiple wave and tidal pilot projects. The EU is also supporting marine energy as part of its goal to be carbon neutral by 2050. Now, hydropower without dams might sound futuristic, but it's already here, quietly powering homes and helping the planet. And as we look for a cleaner future, more sustainable energy, ocean-based power could be the next big wave.